video, we're going to take a look at the top 10 Wireshark filters that I like to use for setting display filters. So probably the reason you're here is because from time to time we might need to set a filter and we don't quite know what the syntax is for it. So here are some common ones that I like to use, and no doubt they will be of use to you as well. So the first one that I like to use, and this is a very common one, perhaps the first one that I set in any trace file, and that's just a station filter or an IP filter. And that's when I want to show any packets to or from a certain IP address. So what I do is I come up to the address or the filter bar and I type in ip.addr. Now what that does is that gives me either this IP address that I'm going to specify as a source or as a destination IP. If I wanted to be more specific and only have that IP as either the source or the destination, that's where I would make a change here. I could either type in ip.src to be the source or ipdst to be just the IP destination. Now you notice in the background, anytime that you get a syntax right, then you'll see that the background turns green. That means that you got it correct. You got the right syntax for what you're looking for. Now if you type something wrong, like address, for example, that's going to be red. That tells us that Wireshark does not recognize that as an appropriate display filter syntax. So I'm going to back up there. So back to my original filter, ip.adder equals, and then the IP address that I want to filter on. What that does is it'll filter out any packet that does not match this filter as either the source or the destination IP, and it'll only show me conversations to and from that station. Now the next thing that we may want to do is to set a filter for a protocol. Now that's pretty simple as well. If we come up to our filter bar, I'm just going to clear this conversation filter that we sent, and that's when we can type in whatever the protocol may be. It could be ARP, it could be TCP, it could be DNS, it could be HTTP, whatever the case may be. That's a pretty simple one to filter for, and remember that your green bar will always turn green when you've hit the nail on the head. Now it could be that you want two protocols to be displayed. For example, you want to display both DNS and HTTP. Now what we do is we'd come up to the top and we would type in DNS. That would be our first application. Now the mistake that's easy to make is we could type in DNS and HTTP. What this does is it requires a packet to be both DNS protocol and HTTP protocol at the same time, which is impossible. So we don't want to use the AND switch there. Instead, we want to go in and say DNS or HTTP. What that does is it will display only the DNS traffic and HTTP traffic that we have in this trace file. The next filter that we may want to set is a common one as well, and that's for a TCP or a UDP port number. So if I come up to the top, I can clear out what I was working with before, and I can type in TCP dot port. What that does is it sets a filter for a specific port number that I then specify. Now of course if I want this to be UDP, I could put UDP.port. Now since I don't have a port source or port destination specification in this filter, it will show me all packets with that port as either the source port or the destination port. And this is a good filter to keep in mind if we're looking for a real specific port number that might not have a protocol associated with it, or maybe even an ephemeral port on the client side. Now the next filter that we're going to look at is one that's good to use when we're digging for packet loss or retransmissions on the network. And this is a filter that will show us any TCP problems in this trace file. So again, if I come up and I clear the previous trace file out, I can come up to my filter bar and I can type in tcp.analysis.flags. Now Wireshark can flag TCP problems in the trace file wherever they may occur. And what this filter does is it only shows me those flags. It shows me the problems that Wireshark has identified in the trace file. So you can see, for example, here we have some duplicate acknowledgments, a retransmission, a TCP previous segment not captured. Now all of those may indicate packet loss, it could be window problems, whatever those TCP issues are that Wireshark has already flagged. This is an excellent filter to use if we're just trying to quickly identify whether a problem is rooted in the network or if it's rooted in the application. The next filter we're going to take a look at is how we can remove some of the noise when we're looking at a trace file. It's already hard enough to look through these lines of code and dig in and try to make sense of what's really happening, with also having spurious protocols or applications running that aren't really helpful to what we're doing. So what I'm going to do is go up to the clear button again, and let's go up to our filter bar. And we want to create a list of protocols or applications that we're not interested in looking at. So to do that, to remove them from the trace file or to filter them out, we would first use our not symbol. Then we would do parentheses. Now this is if I want a list of things. So a common one that I'll do is I'll say ARP or DNS or ICMP, just for example. What this will do is it will remove ARP, DNS, and ICMP from the trace file and only leave whatever is left. And this is what we call pruning the trace file. It's cleaning up these extra things that may not be helpful to what we're really digging in and trying to find. The next very common display filter that we're going to look at is how we can follow a TCP stream. Now what we mean by that is when we just want to focus on one single TCP connection. Now we could do this manually up in the filter bar. We could type in the source TCP port, the destination TCP port, and set that as a conversation. That can get a little complicated. But to do it quickly with Wireshark, I'm just going to come up to my clear button again. I can select any packet in a TCP conversation that I'm interested in looking at, right-click it, and then go down to Follow TCP Stream. Now initially this will bring up the follow TCP stream content if there is any content in the TCP packets in that stream. I'm just going to close this, and what I will see here is any packets that are related to that TCP conversation. So notice my ephemeral client port, my server port, my SYN/SYN/ACK ACK, then I see a spurious retransmission. These were the only 5 packets involved for this trace file in that one TCP connection. Now alternatively, I could have gone up to the TCP.stream equals 32 filter, but most of the time that's not how we set these. Instead, we just look at a packet that's involved in the connection we want to filter on, right-click it, and set that TCP stream. Now, sometimes we may want to set a filter not for a port or for an IP conversation, but for a text word. Maybe we're digging for a certain username, or we want to see if there's a certain tab name in an application that's sent in the packets. So to do that, it's a simple filter. We can come up to clear, and this time we're going to use what's called the TCP contains filter. Now here I can type in any clear text word that I want to, and anywhere where that word may appear in any packet in this entire trace file will be displayed. So for example, I can do TCP contains Facebook if I'm interested in seeing which devices are out there talking to Facebook. Now once I set that filter, if I come down into the clear text view within Wireshark, I'm going to just scroll over because on mine it's a little hidden. This is where I can see where that actual word appears. I see facebook.com. Now remember that up here I set a filter for any TCP packet that contains the word Facebook. But just as easily I could wipe this and I could type in UDP contains Facebook, and that would show me all of my DNS queries to Facebook or that have that word Facebook in the packets. So again, this is a very useful filter if we're looking for things like Facebook or a username or perhaps a torrent user. And again, that's the TCP or UDP contains and then the string. Now from here we're going to take a look at a couple very useful application filters built into Wireshark. Now specifically these involve HTTP. Now HTTP, as we know, it's an application that uses requests and responses from users. So I'm going to come up and clear my previous filter out. I'm going to come over to my filter bar and I'm going to type in http.request. What that will do is it will display all HTTP requests involved in this trace file. I can see all the gets, I can see all the servers involved, all the clients involved, if there's any retransmissions as we see here. I'm just going to bring my hex view a little bit out of the way there. Now it's also possible that I want to filter for a specific response code. So I could go up to the bar up here and I can back out request and I can type in response, come down to code, equals, and then I could type in 200 for the OK responses, or 404, or 500 if I suspect I have a server error, whatever the case may be. And that will filter only for the HTTP responses. So those are also some useful filters when I'm doing HTTP analysis. Now we're just going to look at 2 more display filters in this video, and one of those is more related to security. So I want to set a filter to see if one of my servers is getting SYN attacked. I want to see how many SYN connections are coming into a system, where they're coming from, and what those ports look like. So to do that, I'm going to clear my filter, and I'm going to come up to my filter bar. I'm going to type in tcp.flags.syn. What I want to do is I want to be sure that all packets with the SYN bit in the TCP header set to 1 are displayed. So this means show me all SYNs. And what I'm going to look for in my patterns over here in the information, I want to look for rapidly incrementing SYN connections coming from one station or two stations or whatever the case may be into a server. And what that will indicate is that server is being attacked. So there will just be a single destination, and these will be coming in very quick, and likely there will be thousands and thousands and thousands of them. Now it's also possible I could use this flags filter to look for things like TCP resets. And to do that, all I got to do is remove the SYN and type in reset. And that will show me all TCP resets that are in the trace file. Now the final Wireshark display filter that we'll show in this video today has to do with voice over IP. But since I don't have any voice in this trace file, I'll just show you what the filter looks like. If I come up and I clear this one, now with VoIP, it has both a signaling protocol and also an RTP stream. So if I just type in SIP, that means that I'll just get the signaling between a phone and the call manager, or that call manager and the remote phone. If I type in just RTP, then I'm only going to get the RTP stream between those two phones. But to see both, I can type in SIP && RTP in order to get both of those together, both the control and the RTP feed. Now I hope this top 10 Wireshark filters video was helpful for you. If you have any other questions, please feel free to comment in the line below. Or if you have other Wireshark filters that you like to use, that you'd like to share, also please add those as well. Thank you for watching this video by Packet Pioneer. If you're experiencing network or application performance problems and you need help resolving them, please get in touch with us at www.packetpioneer.com or by sending us an email at packetpioneer@gmail.com.